Today's lesson is on fractional exponents and radicals. And what we're going to learn is if I have a radical, how can I write that as a power with a fraction as my exponent? And vice versa, if I have a power with a fraction as my exponent, how can I rewrite that so that it looks like a radical? So in order to do that, we have a rule. And the rule says that if I take a power, so for example, x to the m over n, and keep in mind that these are going to be numbers, I can rewrite it in the following way. The base, which is x, will become my radicand. My denominator, which is n, will become my index. And my numerator, which is m, will become my new exponent. So that's one way I could write it. Or I could take the exact same power and I can rewrite it in the following way. I can take my base, which is x, and that still is my radicand. My index is still n because that's my denominator, but instead of writing my exponent outside of brackets, I can take my m and just write it underneath the radical as an exponent to the radicand. So this is two different ways that I can rewrite a fractional exponent as a radical. So if we want to do an example, we want to evaluate these two powers with fractional exponents, and we want to try to do that without using a calculator. So in order to do that, the strategy is to rewrite each power as a radical. So if we look at the first one, our base is a -8, so we want that to be our radicand. And our index is going to be the same as our denominator, so that's a 3. And our new exponent is going to be the same as our numerator, which is a 1. So now that we have it rewritten, we can evaluate it. So what we have to do is we have to evaluate the radical first. So the cubed root of -8, in other words, what number can I multiply by itself 3 times to give me a -8? That would be -2. And now I need to rewrite it so that I have it written to the power of 1. So -2 to the power of 1 is just -2. How can I use this strategy to help me when the base itself is a fraction? Well, we do it in the exact same way. The base is 16 over 81, so that is our radicand. Our index is the denominator, so that's a 4, and our new exponent is a 1. So I have to solve each piece individually. So I want to know what is the quartic root of 16 and what is the quartic root of 81, and I want to raise that to the power of 1. So the quartic root of 16 is 2, because 2 times 2 times 2 times 2 is 16, and the quartic root of 81 is 3. And I've got to raise that to the power of 1, and anything raised to the power of 1 is just itself. So the answer to that one would be 2 over 3. If I look at example 2, we want to take each of these radicals and we want to rewrite them in exponent form. So if we look at the first example, we have the square root of 3 to the power of 5. Now from grade 8 and grade 9, we should remember that if there's no number written in the index, it's understood to be a 2. So if I use my rule from the beginning of the lesson, the radical is a 3, so that becomes my base. The index number is my denominator, so if there's no number in the index, it's understood to be a 2. And my numerator is my exponent piece, so that becomes a 5, and my answer is 3 to the power of 5 over 2. Likewise, if we look at B, we want the cubed root of 25, all squared. So my radicand is 25, that's my base. And I want to write my fraction, so the index is a 3, that becomes my denominator. And my numerator is going to be the 2 because that is the fraction, or sorry, that is the exponent outside of the brackets. So my answer is 25 to the power of 2 over 3.